here we go. Lots covered today, okay? After robbing a bank in Dodge City, a robber gallops off on his horse at a speed of 14 miles per hour. 10 minutes later, the marshal leaves in hot pursuit at 16 miles an hour. How long does it take the marshal to catch up to the bank robber? Do you agree that the marshal's going to catch him at some point?
At some point.
Unless the robber sneaks away somehow.
No.
No.
It is going to take him so long to catch up to the robber. The robber's going to be in a hiding place before he can catch him.
Does everybody agree that this is a rate, distance, time problem?
Yeah.
So that's the first question: is can you classify it appropriately as rate, distance, and time? The second question is do you know that rate is distance over time is the same thing as rate times time is equal to distance if you just multiply both sides by t? Or if you divide both sides by r, we have time is equal to my distance divided by my rate. You have three different equations. So which one do you use? Okay?
Probably the one that says time.
Me too.
The one that
D
equals
equals
time.
Yeah, because how long
Does
does it take the marshal to catch up with the bank robber?
So there's actually three different ways of setting the problem up. I like to choose the one in which we define which element is the same. So as they've been running after each other, are their rates the same? No, the rates are not the same. Have they been traveling for the same amount of time?
Yes. No.
Nope, the robber's been traveling 10 minutes longer, right? Because he got a head start. It does work to set it up as time. However, I think that, in my opinion, it's easiest to see that we set up distance, because when one overtakes the other one, that's when they finally traveled the same distance. Get my point?
That makes sense.
See that? So when I'm doing rate, distance, and time, I like to think about what variable is the same. So we want to know this question. When is the robber distance equal to the marshal distance? Well, I have this equation right here, which talks about distance. Distance is the rate times the time. What is the rate of the marshal?
16.
16, and we don't know how long it takes for him to catch up to the robber, so we do t. Okay? And then what's the robber's? Robber's distance is rate times time. What is the robber's rate?
14.
Times his time. But he has more time than the marshal, doesn't he?
10 minutes.
He has the head start. Okay? So we would have not just t, but t
Plus time.
plus, it's in hours.
Oh, it's in hours.
It's in hours. So 10 minutes would be, how much of an hour? 1/6, yeah. So time plus 1/6 of an hour. So it's important that you understand that the distances will be the same, but the times will be different. So this is one way to set it up. 14 times t is 14t. 14 times 1/6 will be 7/3. Is equal to 16t. I subtract 14t, I get 7/3 is equal to 2t. I divide by 2. Dividing by 2 is the same as multiplying by 1/2. I get 7/6 is equal to t. What does that mean?
Hour and 10 minutes.
Yes. 1 hour, 10 minutes.
And that's our answer.
Yep. Yet I don't pretend that any of this is easy. I don't. But I do know that all these are important ones that we model. We are not going to do that problem.
Whoa.
I love that problem. It's one of my very favorites that we do in class, but we just don't have time for it. We're going to move on to this, but before we do, let's turn to your homework so we can look at what we should work on and what we should not. So we talked about everything on the front page is stuff that should be right up your wheelhouse, okay? Backside gets a little bit more difficult, but 13 and 14, or I mean 12, 13, and 14, 15 and 16 and 17. Yesterday we talked about 18 as well. You're now ready to do 19 and 20. You don't need to do 21. You can cross that off.
Ever, we're never doing it.
22 is very optional. 22 is an awesome problem. I would love it if somebody tried to work it out and got the solution. I would say only, once every couple of years I have somebody who tries it and gets it. I have a number of people who try it and they want me to guide them through it. I'm not going to help you with 22 at all. Eventually I'll help you with 14, but if you try 22, like that's like you.
Give it our
You're
best
in it.
shot. Give it our best shot.
Yeah, if you want to try it, go ahead, but you're not expected to do anything with it. Okay, but those should all be modeled after problems that we have done. Okay, very, very similar. Look to your notes and try to allow those to give you some guidance. Okay, so let's move on to the next type of problems. The next type of problems involve what we refer to as optimization.
2.7 notes. Let's go. Optimization, be optimistic.
Like the glass is half full.
What?
Like the glass is half full.
Optimization means, and we talked about this earlier, and we're getting to this, and this is really kind of getting towards the heart of the application of mathematics, is, again, when Kenzie got her drink right here, we said, this is not the optimal way to make use of this amount of aluminum. Rather, my can of Mountain Dew is the optimal size, isn't it? Okay, it changes to give it a different kind of appeal. There's actually a marketing strategy, okay? Drink this and you'll be slimmer because there is less calories in here compared to Mountain Dew, right? And is that true? Absolutely, right? Absolutely. In fact, I was just doing some research area because I love Mountain Dew. You guys know Mountain Dew has, one can of Mountain Dew has 170 calories. Yep. Do you know how, if I were to, let's say I would not consume Mountain Dew on a given year, and then the next year I would have 1 can a day. In addition to the other things, I consume 1 can. Do you know what that will result to in terms of pounds by the end of the year?
Probably like 50.
That would be a major calorie.
15 pounds. 15 pounds just from a can of pop.
Well,
yeah. You know what I mean?
That's a lot of cans.
Yeah. And so
it is.
I had this awkward thing that happened to me. I think I told you guys this a while ago, but about a year ago, I just out of nowhere, I was diagnosed type 1 diabetic. Okay, my brother is diabetic. He has been since he was 7 years old, and all of a sudden it hit me. Okay, I have to take insulin and all sorts of stuff like that. But so I can't. My body doesn't handle sugar the way that other people do it. It doesn't handle carbohydrates. So like if I have potatoes and stuff, it doesn't like that either. Okay, so I eat a lot of protein, nuts, stuff like that. But so I used to consume 5 Mountain Dews a day.
You can't do that anymore.
And then I went down to 1 a week. It was hard, but I did it. 1 a week. Over the course of that year, I'm not kidding, it was about a year and a half, I dropped about 23 pounds.
Holy smokes, Mr. Old.
Yeah, it was significant. Anyway, yeah. So, enough talk about pop. We get to our optimization piece, and we're going to talk about a farmer. This farmer is desiring. Yep, this is Farmer John.
Oh, it's Joel.
Farmer John.
It's John.
It's John.
He's making a pen on a 480 yards of fencing. He's going to be dividing that pen into 3 sections that are all equal in size. This is going to be a rectangular pen, not a circular pen. So I'm going to draw this rectangle, divide it into 3 parts. John, why would you want to make a pen and divide it into 3 parts? For what purpose? Separate the animals?
Oh, look at
okay.
this guy's-
Why would you want to separate the animals? Why can't they all just be together and live in harmony? Disease? Yeah. sometimes you don't want certain ones to procreate with the other ones, right? You control breeding as well. Yeah.
That could get nasty.
Why would you want those pens to be as large as possible? Fit more animals in there, and you may have a minimal area requirement that animals need to have in order to meet, say, county statutes or whatever that, or have a certain certificate for your marketing, whatever like that. So this is an important question. It really is. And I've found over the years that when we encounter these kind of problems, that it is best for students to make 4 boxes. I don't just have these 4 boxes here for us to organize our work, but that you might actually do it in your work. I always model the problem here. I write down some formulas here, I put the equation here, and I solve it over here. So when you don't know where to start, draw your boxes and get going. Calculus, they learned it last year. They all do it right away, like this. So what dimension should he make the pen in order to maximize the area? That is the most important part of the problem, and that is what we look to in order to determine our next steps. This is what makes it different from the other ones. Notice that this one says maximize. So if you're on your test and you're looking at problems like this, this just says how long will it take. It doesn't say what is the least amount of time. You get my point? If there's a minimum or maximum component to it, then we take these strategies. Maximize area. So I'm going to write down a formula for area. Area of a rectangle is the length times the width. So I have length and length. I have width and width. But I have a problem. I have 2 variables. We talked about yesterday, if you have 2 variables, you need 2 equations. So I need to come up with a second equation so that I can get rid of one of the variables. How could I use this bit of information to come up with another equation? Perimeter, okay? So L plus W is 480. Except we have more than just W plus W, don't we?
You have the other two.
We have to do these 2 as well. So 4 of the W's plus 2 of the L's is going to be 480. So that's our restriction. It's like, well, why not just make the pens as big as you want? Because we don't have an infinite number amount of fencing. We have 480. Okay, we're trying to make use of what we have. Well, great. I now have this equation. This is the one that I want to use. This is the one that's driving the problem. This is the one that's going to help me out. And watch how it helps me out. If I subtract a 4W from both sides, I get 2L is equal to 480 minus 4W. And then if I divide by 2, I get L is equal to 240 minus 2W. Now that I know what L is, I can take it and substitute it right in for L right there. And so I have my equation that will represent this problem, area. And it is now all in terms of one variable. That variable would be W, is equal to 240 minus 2W times W. I'm going to pause. Any question how I got to where I am right now? Because once you get here, like once you get the second box figured out, this is the hardest part. If you do box 2, you do the whole problem. Now it's easy. I just distribute the W. Area in terms of W is equal to 240W minus 2W squared. What shape does that make? It's a square. What shape? Parabola? This makes a parabola, right?
Mm-hmm.
Right side up or upside down?
Right, upside down.
Upside down parabola. Does that parabola have a maximum to it or a minimum?
Max.
It has a maximum. Are we trying to find a maximum?
Yes, we are.
We're absolutely trying to find a maximum. What do we call that part of the parabola?
vertex.
The vertex. What's our equation to find the vertex of a parabola? We learned it, so it's lodged in our brain somewhere. Now we're focusing on the retrieval process.
It is on the retrieval process. It might take a while.
I like what you're thinking. That's for a line, but good thought.
Great thought, John. You got farther than I did.
Negative b divided by 2a. Does that ring a bell?
Yeah.
So negative b is negative 240 divided by 2 times a would give me negative 4. Negative 240 divided by negative 4 is
60.
60. And notice that the vertex has an x-coordinate and a y-coordinate, okay? We just found the x-coordinate. And in this problem, x is represented by w instead of x. So we found that the width is in fact 60. Look at the problem. It says the farmer's making a pen out of 480. What dimension should he make the pen to maximize the area? We know that the width is 60. How could I figure out what the length should be?
Plug in 60.
Yeah, it says right here the length is 240 minus 2w. So you just plug it in right there. 2 times 60 is 120. 240 minus 120 is 120. So this is going to be 60 yards by 120 yards. Pretty big pen. But at least we're farmers who think about it instead of just putting it up. Which one do you want to be? You want to be the one who does it the right way.
Yeah, probably.
Oh. Okay. So our focus over the next couple days is to work through problems that involve maximizing and minimizing. That's what we want to do. Okay, maximize and minimize. I can teach you how to do box 1, box 3, and box 4 really, really well. Not much to it, okay? But box 2, that's where the magic happens. So we're going to quick practice how to do box 2, and we're going to do 2 more problems together, and that's where we'll be today. Okay? So I'm only going to focus on box 2. It says find a function that models the real-life situation. The sum of 2 numbers is 24. So x plus y is 24. Any question how we came up with that? Kira, can you give me 2 numbers that add to 24?
21 and 3.
21 and 3. 21 times 3 is 63, right? Give me 2 more numbers that add to 24.
14 and 10.
14 times 10 is 140. So this problem says find a function that models their product in terms of x, one of those numbers. So what I'm doing is I'm taking your 2 numbers and then I'm multiplying them together. Okay? See that? So yours produced a smaller amount, yours produced a bigger amount. Okay? So find a function that models their product. So that's what's driving the problem. Product is equal to x times y. So I want to use that one because that's what the problem is saying. Find the product. What could I do to this equation that we first wrote in order to get rid of x or y?
Subtract the y on the other side.
Yep. So x is equal to 24 minus y. Now you can take that 24 minus y and you could drop it in for x right there. So product is equal to 24 minus y times y. Now, it does say find a function that models the product in terms of x. So technically we should have not subtracted y, but we should have subtracted x. But it looks the same, it just has an x in it instead of a y. Get the idea? Okay, that's it. So that's the challenging piece to come up. What I want you to do is I'm going to do A and C, but I would like you to try B right now on your own. See if you can come up with a formula that models that situation. Try something. You need to start with drawing a little picture, that's fine. Go ahead. Here are 30 seconds here. So it says find a function that models the area, so that's what I want. One piece that I know is I know the length is 8 more than the width. So you could take this and substitute it right in for L. So I'm looking at the area in terms of width is equal to W times 8 plus W. Or if you wrote it as 8W plus W squared, that would be correct. Thumbs up if you got that one on your own. Good job. Okay, I'll do another one for you, then you're going to practice one, and then we'll move on to our other two problems. A rectangle has an area of 40. Find a function that models its perimeter in terms of the length of one of its sides. Oh boy. It's a little bit different. It models the perimeter. What is the perimeter of a rectangle equal to?
2L plus 2W.
Good. Now on this one, we're not given perimeter, we're given area. Turns out that the area is 40. So in other words, you know 40 is equal to the width times the length. So I'm going to use this to eliminate one of the variables over here.
Where'd you get 2L plus 2W?
So that's how we calculate the perimeter of a rectangle. We have two lengths and we have two widths that we add up. And so I'm just going to divide by W. And notice I get the equation L is equal to 40 over W. I can now take the 40 over W and I can drop it in for L right there. And so I get the perimeter is equal to 2 times 40 over W plus 2W. If I multiply by 2, I just multiply the top because this is 2 over 1. So I have perimeter is equal to 80 over W plus 2W. Now I have an equation that has one variable in it, not two. You can't have two, you got to get it down to one. You try letter D on your own. There are 30 seconds to think about it. Zoe, I heard you guys beat Northfield.
Nice.
Did you trash talk them afterwards?
You should have. You should have said that's in your face. Just like these kicks were in your face.
All right. Does everybody agree that the box is taller than it is wide or deep?
Mm-hmm.
Okay. And what we know is that the bottom is a square base. That means that the bottom has the exact same dimensions. And that's key. how does the height compare to the depth?
3 times.
It is 3 times that. And if we're writing an expression for volume, volume is equal to length times width times height. So I have my length, I have my width, I have my height. And so volume is equal to 3x cubed. Or 3w cubed, or 3l cubed, whatever you chose to use for a variable.
I did D for depth.
And you wrote 3d cubed?
I wrote 3x cubed because that's what you had.
Oh, and using d is just fine. Okay, so I understand that coming up with some of those pieces is challenging. That's why I'm not going to expose you to something on the test that you haven't seen before. Flip it.
3x cubed.
So the way I come up with volume is I multiply the dimensions. So I have 1, 2, 3 dimensions. As I multiply all 3 of those, I get 3x cubed.
Okay, so why is it just x for? Why is it just x for those 2 then?
So it says that it has a square base. That means that this base, it has the same length as it does the width. So that's the same. And then this is 3 times that.
That's way more simple than that.
Okay. Problem number 3, we're skipping that and we will move to this type of problem. Farmer is building another fence. Okay, so now let's get back to applying this. This time he's building it against a barn. He's a smart farmer because if he builds it against a barn, he doesn't need fence there, right?
Oh, he's such a smart farmer.
Way to go, John.
Yeah, but not you, the other John.
What is the goal of this problem? Maximize area. That tells me the equation I write down. Area equals length times width. What else could I write down to help work this problem out?
Remember?
2w plus L minus length of the bar.
If I have 2 widths and 1 length, that adds to the amount of fencing I'm going to use, which is
320.
320. Good job, Peyton. There you have it. You have 2 equations, you have 2 variables. We are going to solve L equals or W equals. Do you think it's easier to have L equals or W equals in this situation?
W.
Watch what we do. Suppose that we were to solve W equals, you would have 2W, don't write this down, is equal to 320 minus L. And then you would divide by 2 and see how you get L over 2. That's totally allowed. However, and you could do that, come up with the right answer. However, I think it's kind of nice in this situation to just subtract 2W and notice how the L is all by itself then. So you get choices. I just think that this one looks a little bit nicer. I can now take what L is and I drop it right there. So the area in terms of W is, I have 320 minus 2W, and I multiply that by W. I distribute the W through, I get area in terms of W is equal to 320W minus 2W squared. What shape does that make?
Parabola.
Right side up or upside down?
Upside down.
Does it have a maximum or a minimum?
Maximum.
It's got a maximum. What do we call the maximum of a parabola? Vertex. Do we have an equation for the vertex? What is it?
Over 2a.
Negative b divided by 2a. Sweet. Problem's easy now. Negative b would be negative 320. Divided by twice the a value, that'll be a negative 4. And I get out of that 80. And you can see in this problem that we've chosen 80 to represent the width. How do we get the length?
Plug in 80 to 320 minus
Yep.
2W.
320 minus 160 is 160. So 80 by 160. So again, the farmer is not just building any fence or enclosure, he's building one that maximizes that area. Okay. Last example. A box with an open top is to be constructed from a rectangular piece of cardboard with dimensions of 10 by 18. So I've got a 10 by 18 piece of cardboard. And there's going to be squares that are cut from each corner, and then we're going to fold the sides up. Have we seen this model before?
Yeah.
Yep, I did this with you guys the other day. So we're going to cut a corner here. We're going to cut a corner here. Cut a corner there. And cut a corner here. What is driving the problem? What is the goal of the problem?
Find the largest volume.
Largest volume. So therefore, I write the formula for volume. Volume is length times width times height. Is the length going to be 18, more than 18, or less than 18?
Less than 18.
By how much?
X squared.
Close.
2x.
By 2x's, right? So the length is 18 minus 2x's. How about the width?
10 minus 2x's.
Width is going to be 10 minus 2x's.
So where'd you get the 2x?
So if you notice, let's say that we cut off a unit of 3 here and a unit of 3 here. There'll be 18 minus 3 and minus 3. So it'll be minus 2 of those 3's.
Okay, I still understand.
So we're getting rid of, so we're going to cut that off. See that? So if you're going to find out the new length, you take 18 and you subtract 3, and then you subtract another 3. You subtract 2 of those 3's to find the new length. So you're going to subtract 2x. And the width is 10 minus 2x. What's the height? When you fold this up, when you fold it up, how tall is it going to be? X tall. Yeah. It's going to have whatever size you cut, that is going to be the new height. And so we have now an equation for volume in terms of x. We have the length, which is 18 minus 2x. We have the width, which is 10 minus 2x. And we have the height of x. Volume in terms of x is, I'm going to multiply this all out. 18 times 10 is 180. 18 times negative 2x is negative 36x. Negative 2x times 10 is negative 20x. And negative 2x times negative 2x is positive 4x squared. As I combine my like terms and I distribute my x, I get 180x. The negative 36 and the negative 20 make negative 56x squared. And the 4x squared times x will give me a 4x cubed. Does that make a parabola?
It makes a ooh.
Good, makes a cubic. That also has what we call a maximum. It also has a minimum. We are interested in the maximum. You can't use negative b over 2a if it's a parabola. We have to turn to our calculator. Take out your calculator, see if we can get it.
We need a cow.
Type in 4x cubed minus 56x squared plus 180x into your calculator. We're going to be right up to the bell on this. Please hang tight. Everybody got it? Okay, zoom standard, zoom 6, please. Let us understand the problem. If I go back to the problem, if it is 10 wide, how much could you cut off for x? What is the most you could cut off for x?
4 and 4.
4 and 4, because that would be 8, or like 4.5, right? Or like anything less than 5, right? Like 5 is like, you start cutting 5 off, you got nothing, right? And then for the 18, the most you could cut off would be
9.
Hey, got anything less than 9, right? So look at what your graph does here. It crosses the x-axis at 5 and 9, because that's what would produce 0. But you can't see the top of it, can you?
Mm-hmm.
So I should change my window. What should we change on our window?
Again, I only got one line on my graph.
Okay, what should we change on our window?
1,000.
Change it to 1,000 or 100.
1 million.
No, that's too much.
You'd probably be able to see the whole graph.
No,
You can see.
it never ends.
You can see the whole graph at 1,000.
But I bet you still
What about
see
100?
a million.
I don't know.
Try 100. I bet you'll
Try
see it.
200.
I bet you'll see it at 100.
All right,
Oh, of course.
graph it. Oh my God, we didn't see that.
Oh, I was wrong. I'm
Let's try 2,000.
So if you change the y max to say like 50, notice as we look at the graph, we don't see the top. Let's choose a bigger number. What do you want to go more than 50?
200.
Sure, let's try 200.
100 was not enough. We already.
I can now see that. How do I calculate the maximum using my calculator?
Second.
Second calc.
Second calc,
Max.
maximum, number 4.
Oh shoot! Second.
Then what do I do?
Then you go over to the other
Yep.
side of it.
Good, so I'm going to go to the top, and
Second
once I get to the top, I'm going to go to the left, and I'm going to go to the right. Press enter on each, then I press enter on guess, and I get 2.06 and 168.1.
I remember when we were doing this every day.
68.
2.06 and 168.1. Now as we finish here, okay, we're right up against the bell, but look at what this represents, okay? 2.06 is x, 168.1 is y, or the volume. What is the problem asking for?
What's the largest volume?
And so the largest volume is 168.1 inches cubed. In order to achieve that, you cut a 2.06 square out from each side.
Wow.
I don't know if you want to take it. Please look at your homework so I
That's
can
sick.
guide you to the right problems to look at, not the wrong ones.
That's sick.
That's sick.
3, 4, and 8. Please circle 3, 4, and 8 on the applications. Do not try the others. 3, 4, and 8 are going to be the best ones for you to look at. They model very closely to what we just did. Not the unit you want to fall behind in, folks.
So, do not fall behind.
The top. No. Now that you're at the top, move left. See how it's like left bound? So you got to be left of the top, and then you have to be right of the top.
Really?
That is early.
I can't.
Yep. I got it.
That is early. You can know that this morning, Billy.
So 2.06, that's the size of the square that you need to cut. A 2.06 by 2.06. If you cut 2.06, that's going to produce a volume of 168.1.
Oh,
Not
Why
bad.
isn't this?
Hey, it ain't bad. Hey, I mean,
Because in the problem, x is x, the y is b.
No, it's not that
We're doing
bad.
word problems too.
See, the output is, the output is b.
Oh, gotcha.
So that's your y values.
NT, let's go.
So what did
NT.
you guys get done yesterday? Because I wasn't.
Yeah, we did about 7 word problems from the previous section, so I think I have the video posted online. So,
When can I come in to like open my?
what works for you? The after school. See you then. Sounds good? Yep, which one are we looking at?
1 to 1 6.
The first one?
Yeah,
Got it.
Thursday I'm gonna come in. I think. I'll probably come tomorrow morning.
Sounds good. Excellent, very good.
Thank you.
Is it true you were talking about me yesterday?